Hello guys, welcome back to my YouTube channel. In this final phase of building GraphRag, I'm now going ahead to show you how we can build a GraphRag. So the reason why I'm telling you this one is because you can see over here, based on my knowledge base, that is a hysterectomy, the most accurate rag that we have here is GraphRag. Okay, the next most accurate one is multi-query rag that we talked about. Then after that is a hybrid that uses dense search and sparse search. And then hypothetical document drag is the third one, and then naive one is the second from the last, and then hierarchical one is the last one. Okay, so that is based on the quality you can see over here. So I'm just going to show you, let me just show you the diagram of GraphRag that we shall have over here. I'm now going ahead to run this program so that you can just go ahead and see. Okay. So the question that we have for GraphRag is how does the sequence of ligament cutting relate to the risk of urethral injury, and specific ligaments are more dangerous? So we are just, first of all, it has to build a fallback vector store. That is important. It will go ahead and help us in the subsequent step in building the knowledge graph. Now it is extracting the triples, that is the subject, predicate, and the object. Once it does that, so these are query entities, ureter ligament, urethral injury, traversing, that is multi-hopping for reasoning, ureter ligament, it goes ahead, and now it will go ahead. Oh yeah, it has gone ahead. It uses a supplement of the vector stuff that falls back over the other side and gives us a final answer over here. So what is the answer? The answer says the sequence of ligament cutting during surgery is crucial in minimizing the risk of urethral injury. The procedure should begin by cutting ligaments that are distant from the ureter. So this just answers related to hysterectomy. So you can study about it. I'm using hysterectomy as a source of source data over here. Okay, so now let's go back to understanding what's a GraphRag. So instead of retrieving flat text chunks like we do in naive RAG, GraphRag builds a knowledge graph from the document. So it has the nodes and the edges. The nodes become the entities. The edges show the relationship between these entities. So in this situation, so at query time, what happens is that it extracts the query entities and then goes ahead and finds those entities in the graph. So once it does that, it traverses the graph that is hopping from 1 to 2 graph to collect related facts to the question. Okay. Then it passes the question, passes the graph subgraph as structured context to the GPT, that is to the LLM in this situation. So why do you have to use it? So multi-hopping reasoning. So for example, what instrument is used in the steps that comes before mobilizing the bladder? So that is, it helps, it just goes ahead and studies the steps that are out there. And then explicit relationship tracking. It goes ahead and tracks the relationship between each and every entity. In this situation, it might be as you can see over here. In a previous situation, I showed you, okay, let me just run it again because you might need it in the next page. So the multi-step goes back in building in knowing the entities and the relationship. That is really important because we have to build the graph. So coming back to our code base over here, we are building a RAG. The first step, as you know, we have to ingest this data, and our source data comes from the URL. So we scrape it, that is over. After scraping, we build a vector store. So we keep our vector store as a fallback in case the graph doesn't have enough coverage for query that the user has. So GraphRag plus the vector store fallback is just a common methodology that is used in production pattern. So once we do that, we extract the triples. What are the triples that I was talking about? The subject, predicate, and the object. So we ask ChatGPT to just go ahead and extract knowledge triples for each text context. So in our situation, what are the triples that were extracted over here? You can see for the query entity, urethra, ligament, urethral were extracted, and then when it traverses, it did two hops for the entities. It went ahead and searched for urethra, ligament, and urethral injury. So once it extracts those ones, we build the knowledge graph. Okay, building a directed graph from the full document context. So the process involves splitting the text into chunks, extracting the subject, predicate, and the object triples for each and every chunk, and then add entities as nodes. That one I told you from the start, and then relationship as directed edges. So this one results. So the resulting graph lets us find all the relationship as entity, as an entity we have over that side, and then traverses multi parts, finds all entities related to a query entity within the number of hops that the user might have asked the other side. So now we have already done that step. So the next step involves extracting the extract query entities. So based on the question that the user might have asked, we have to extract the entities based on that one. We have already built a knowledge graph over here. Okay. Now once we extract those ones, the next step involves traversing the entire graph so that we can go ahead and retrieve the subgraph over there. This is the subgraph reasoning, is the one that we shall use as our context. Okay, you have to traverse this directed graph. Once we do that, we have to, this is just a formatter, it's just formatting the answer. We have a vector fallback. This fallback is just in case the graph doesn't extract the entities that are relevant here. So we give the formatted graph, subgraph, graph and subgraph to the generator. This is the one that is responsible for generating the answer that the user might have asked. So you can read more about it in Microsoft GraphWag. There's a paper written by Microsoft. You can go ahead and read about it. So this is how I went ahead and built my GraphWag. The first step, as you can see, I always just scrape and build a vector store, build a knowledge graph, and then extract entries from the query, traverse the graph to collect the relevant subgraph, format this subgraph, and then you have to ingest it as a context to the next step, that is the generator. The one that is responsible for generating the final answer. So thank you guys. That is out. I'm going ahead to talk about this one. That is the, okay, before we have to talk about this step, the benchmark. You can see over here, the most accurate one is GraphWag, multi-query, hybrid drag. High drag, and finally the one that is, in my situation, hierarchical drag wasn't that accurate. So in the next tutorial, I'm going to talk about the benchmarking this one. Okay, thank you guys.